Hello everybody. So today I will talk about the system design of WhatsApp. I will do the deep dive and the topic is partitioning. Partition Redis pops up by chat ID or by user ID. Okay, so I will talk specifically about this part today. So I introduced Redis pops up for the fun out of the message, and today I will discuss whether I should do the partitioning by chat ID or user ID. So about this discussion, I will talk about this from two scenarios. So scenario number one is um, each chat room is one-on-one. There exists only one-on-one chat rooms, and each user has 100 chat rooms. So this means that the chat room size is small, but there are numbers of chat rooms. And the second scenario is the chat room is so big, like 100 people inside of it, but each user has only one chat, which means that the number of chat room is small. So I will think of these two kind of extreme scenarios. Of course, in the production system, it should be in the middle ground, and I should adjust the solution according to the statistics of chat room size and number of users, number of chat rooms. Yeah, but for today, I will talk from two scenarios. So scenario number one-on-one chat room, each user has 100 chat. Okay. So I will quickly add something here. So to make this discussion easier to understand, I put real-time message service at the receiver here. So, this is sender. Yeah. So in reality, this service this service is responsible for, of course, both sending and receiving. But just for the clarity, I put two boxes here. So what happens is that some user, probably different user, definitely different user, is connected to another server, and this another server is subscribing to this Redis pub sub. So this is the premise. And now I will talk about the option number one topic user per one chat. So when user sends a message and the message is sent to this server as a sender, this publishes the message to the topic, which corresponds to the chat. And because there is only one another user in that chat room, this topic is subscribed by specific server. So now Redis PubSub has to send the message to one specific server. So what happens here is the sender server has to send the message to one specific topic, and Redis PubSub has to publish the message to one specific subscriber. So far sounds good. But something I have to clarify is that one user has multiple chat. So this is this is good, but for one user, there are many chat. So from one user's WebSocket for one user's WebSocket, it has to subscribe multiple chat. So it looks like this. So this is all about for one specific receiver. Okay. So that's what happens. And for the second option, one topic per one receiver user ID, when user sends the message and sender receives through WebSocket, this sender server sends a message to one specific topic, which corresponds to the other user in the same chat room, which is single receiver, of course. And this Redis PubSub sends the message to the server whose concern is that user, which means that, let's say, receiver is on specific server B. The server B is subscribing to this topic, so this topic sends a message to the server B. So in this case, real-time message service sender sends to one specific topic, and this message in the message in that topic is published to one specific server. So when I compare these two options, both of them are the same. Sender sends to one specific topic. A message in the topic is published into one specific server. But the difference is the number of topics in the Redis PubSub. In the first case, the number of topics is number of chat room, which is 100 times more than user ID, the number of users. So this means that Redis has, it costs much more space, much more memory compared with the second option. So that being said, I will go with the first. Wait, maybe I said wrong. So yeah, the first option takes 100 times memory than the second option in Redis. So I go with the second option. Topic per receiver user ID. Okay, is that it? And of course, because there are many Redis PubSub topics, each server has to subscribe multiple. For each user, receiver server has to subscribe exactly the number of chat that user has. But to be honest, this isn't a big issue compared with Redis memory issue, because the number of connections between Redis server, receiver server, and Redis PubSub is, let's say this is there are n receiver servers, and there are m Redis PubSub topics. Redis PubSub servers, which is an instance, because this is Redis PubSub cluster. In this case, the number of connections is n times m. This means that if there are multiple kind of processes which subscribe to the topic, different topic in the same Redis instance, they use the same connection. So there are only n times m connections between. So actually, as I said, the problems that one server subscribes multiple, topics, which corresponds to the chat, doesn't become a big issue. the true problem is the memory usage in Redis PubSub in this case. Okay, now I will talk about the second scenario. So let's say there are 100 people in a chat room and each user has only one chat room. So in this case, when user sends a message to the real-time message service server, if I take the option 1, this server sends the message to one specific topic which corresponds to that chat. And now the message, this topic is subscribed by multiple users because there are 99 other users. So now Redis PubSub has to send the message to 99 subscribers. This is a fanout here. So that's what happens in the first option. And when I take the second option, when the message sent and real-time message service server receives it, this, as the sender, sends the message to the because there are 99 receivers in the same chat room, each sends the message to 99 topics. So this sender server does the fanout in this case. And then a message in a topic is sent to one specific user because this is now one topic per one receiver user basis. So the message is sent to one specific server to which that user's WebSocket connection is ended. Yeah. So in this case, real-time message service server as a sender does the fanout. Okay, so comparing these two options, the differences are, number one, fanout in Redis or fanout in server. And the second difference is number of messages. In the first case, the number of messages in the Redis PubSub is exactly the number of messages created. But in the second option, because the server does the fanout, the number of messages in the Redis PubSub is 99 times of the original number of messages. So comparing this, I would go with the first option, one topic per one chat ID. Because fanout in Redis PubSub takes less cost than fanout in the server. Because Redis is kind of in-memory data structure, fanout in the Redis is much scalable. To be honest, I'm not super sure and I'm not familiar why it is. But Gemini said so. Maybe I will dive deeper into this reason someday. But for now, my quick understanding is Redis PubSub is more scalable when it comes to the fanout. Okay, and as I said, the latter option, the second option, the memory usage becomes 99 times more. So that's why I choose the first option. Okay, so now I talked about these two scenarios. Yeah, as a quick review, In the first case, I go with receiver user ID based topic. The reason was the memory usage in Redis. For the second scenario, I go with the topic per chat ID. The reason is fanout in Redis PubSub is more scalable than fanout from the server. And also memory usage reason. Okay, that being said, I finished my today's system design practice. Thank you so much. Bye.